Welcome to Math 2320. This is section 8.4. So we are given a matrix A. Matrix A is a square matrix n by n. And we can define E raised to the matrix A times T as essentially a power series, just as we would if we had E to the X as a power series. But in this case, e to the at is the identity matrix plus at, and then powers of a squared, a cubed, ak, and we have this infinite sum. So you might wonder, well, how are we going to calculate this infinite sum? Well, it turns out that in this case, in question 1, A is a diagonal matrix where I've got 1 and a 4 and zeros. And it turns out that if A is diagonal, and it looks like this, just has elements on the diagonal, then it turns out that e to the at is simply e raised to each of the diagonal elements. And so in our case, A is 1, 4 on the diagonal, and so this is e to the 1t, e to the 4t, and zeros everywhere else. Minus A just has negatives on the diagonal, so e to the minus at is simply e to the minus t, e to the minus 4t. Alright, in question 2, we want to use the formula to compute e to the at given here's A, this 3 by 3 matrix. At first, this seems like that could be quite terrible to do, but let's see. A squared is A times A. So here's A multiplied by itself. And when we grind through the calculation, what we see is A times A is all zeros. And so what that says is A to the n is 0. Whenever n is 2, 3, 4, 5, 6, whatever, A to that power is 0. So that means that e to the at is simply I plus at. Alright, so here's the identity matrix. Here's T times our matrix A. And so add them up, and that's what we get for e to the at. So this problem fell apart rather quickly because a squared was 0. Alright, in question 3, we have this system, and they want us to use the fact that the answer is e to the at times our constant. Well, let's see. The good news here is here's A. All the elements are on the diagonal, and so e to the at is simply e to the t, e to the 7t with zeros in the other places, and that's e to the at times our constant. So the constant is C1, C2, and if we grind through the multiplication, alright, so I get C1 ET, and I get a C2 e to the 7t. But I can split this as C1 times e to the t and 0, and then C2 times 0 and e to the 7t, to explicitly write out what is the solution for that particular system.